Hi and welcome to the code experiments for today. Today I'm going to introduce you to 4 important modules you really need to learn because it's very likely that you will use these in the future. These modules will be the CSV module, the glob module, and then we scroll to the very bottom, the web browser module, and lastly the ShotL module as well, which is this one in here. We're going to start with the glob module. Here in the module index page, you'll see that this is about path name patterns. Let me demonstrate you exactly what you can do with glob. So I'm going to create a new e1.py file, and I'm going to create the first experiment here. Import glob, and then my files is going to be equal to glob.glob. So glob is the module and glob is a function of that module. If you right click and then go to implementations, we're going to see that there is a function here. This function returns a list. Let's see what this list is going to be. Now this glob function requires a pattern, and this comes as a string. So here you say what files do you want to filter, what file names do you want to filter. So if you want the text files only, you would do an asterisk .txt and then print out my files, that's the variable, run the script, and you get a list with all the text files. This is very useful when you have multiple files in a folder and you want to perform something to each of them, so maybe you want to loop over them. Let's expand this example to demonstrate you exactly what I mean. Let's say that you have a folder named files, and inside files you have an ideas.txt file, a projects.txt file, and that's it. So please create a files directory and put 2 text files ending with .txt in that folder. So now let's suppose that we want to write a program which prints out the content of all the text files in that files folder. So there could be 100, 1,000, 2,000, 1 million files. Python would be able to go through all of them in just 5 lines of code. So let's write those 5 lines of code. Once you have a list in here, so let's create the list again. This time would be files / everything with txt run, and you get the file names now. Everything else, if we had some other files here, they would be filtered out, so we only get the txt files. And then, instead of printing this out, we could iterate for file in my files, or to be more clear, you can say for file path, because these are actually file paths, they are not files, so we're iterating over the file paths. With open file path in read mode as file print file.read. let's put some content. Content 1 here, content 2 here. Go to e1.py, right click, execute, and that's what you have. So you can access the content of all the files now, all the text files in that folder. Of course, we simply print them out, but you can do whatever you like. You can capitalize the content. You know, you get that capitalized version of the content, etc., and so on. So that is the code to get a list of file paths that satisfy a file pattern, and then you can access the content of each file using a for loop, and inside the for loop you apply the open function to each file path contained in that list. Let's move on with experiment number 2. I'm going to right click over the project directory, the root directory, and create an E2 file. I want to introduce you now to the other module, CSV. CSV is able to process CSV files. What is a CSV file? Well, let's create one. I'm going to right click over app1, go to new file, and create something like weather.csv. A CSV is basically a text file with a CSV extension, and this text file is usually split in columns. For example, let's say we have a station column and a temperature column. And you could have more and more columns, such as date and precipitation, etc. But let's keep it simple. Let's have only 2 here. So station, let's suppose we have data for Kuala Lumpur, and which is 45, and New York 20. So all these data now in a CSV file, they should be enclosed in some characters. Double quotes is advised, so you have every element, every value enclosed in quotes. Although these are not necessary, it is recommended to have them because you see these commas, these denote the split between the 2 columns. So station has these values, that New York, and temperature has these values, 45 and 20. So now that we have these CSV formats, you can have as many rows as you want. Usually you will get these files from somewhere else, some observation stations which process these files automatically, so you might download them from somewhere and then you use Python to open them. So let's use Python to open them and to see the data. Once you import OpenCV, you want to open your data file, which is weather.csv in my case, because this is located here in the project directory and E2 is also in the project directory. So with open weather.csv in read mode as file, data is equal to list csv.reader file. So what I did here is I opened weather.csv as a text file. So you have already learned this line of code, what it does. So we have that file object now. It's in memory. And then this part here, this reader is a function of the CSV module. And this reader function expects a file object as input. So we create that file object using the open function, and then we supply that file object to the reader function. And this will give us something called an iterator object instance. Iterators are also types in Python, but this iterator is not readable, so we need to convert it into a list type. So with that, we're going to get an actual list, and we store it in data. Let's then exit the block, the with context manager block, unindent and print out the data and run. And that is the output that we get. So this is a list of lists, and each of these lists represents one row. So we've got station temperature as the first row. You see that the CSV module is able to split each value of the column, because it knows that there is a comma there, and it also knows that each value is enclosed in double quotes. Now, how can you use this data in real life? Well, you could actually create here an algorithm, and we will do that now, to access the temperature of a given value. So let's suppose that the user will enter a city from the list of cities that are available in our file, of course. Otherwise, we cannot return the data we don't have. So let's say the user enters a city here. Then what we do is we iterate for row in data. Now, if I print a row here, let's see what we get. Say New York. It has to be with capital N and capital Y, no spaces after York, so otherwise you'll not get a match when we write the code now in just a minute. So for row in data, print row, we get access to each list, but then instead of printing the row, we say if row 0 is city, print row 2. I'll explain what that does. Enter city, New York, and I've got this index error, list index out of range. Oh, this should be 1. I'll explain you in just a minute. Let's try New York again, and we get 20. So 20 is the temperature for New York. What did I do here? Well, we iterate for row in data. So row will be a list, because data was a list of lists and each row represents a list. Let me put this here on the side while I talk to you. And row 0 accesses the city, so Kuala Lumpur, New York, in each iteration. So also it matches station, but we can avoid that by saying only iterates from 1 to everything. So for row in data 1 to everything, and let me show you how the data look like here. So you see it, print data, run. So that's how the data look like. Now I'm going to show that code again. So data1 to everything gives us this part only. So the list, actually the list of lists, but without the first list. And then what we do here is we say if row 0, so in each row will be a list, so we check the first item of each list. The first item is always the city, Kuala Lumpur, New York, and so on. So if that is equal to the city, to New York, for example, then we say print row 1. Row 1 means this number, because the row is that list and row 1 is that, or that, whatever matches this condition. So that's how it works. Experiment number 3. E3 is about the shuttle module, which stands for shell utilities. So with shuttle you can copy files, you can create zip files, you can extract files from zip files, etc. So let's try the shuttle.make underscore archive. So this is a function of shuttle, and it expects as output the name of the archive you want to create. So we will get these 2 text files and we'll create a zip file with these files inside the zip file. So we give the name of the output file. We say that this is going to be a zip, so we don't need to say output.zip. We just tell that here. And then finally, we declare the directory where these files are located. So it's important to have the directory with only the files you need to put in that zip file, because all the files of that directory are going to be included in the zip file. And that's it. Run. And here in the same directory with E3, I've got this output.zip file created. It's as easy as that. Let's go forward with experiment 4. Import web browser. And what we're going to build here is a Google searcher, basically. So we're going to receive a search term from the user and we're going to open the browser searching for that term on Google. So let's say we ask the user to enter a search term. Right, we get that search term, we store it in user term as a string, and then web browser has this open function. The open function expects a URL as a string. So if you say here https://google.com, and if you run this script now, first enter a search term, let's say anything, so this will open Google. You see google.com because that's the URL here. But now we want to integrate the term of the user. We want to integrate it with the URL so that here in the search box that user search term is displayed. And the way to do that, to accomplish that search, is first we need to know the search URL for general searches. For example, let's say you want to search for Python website. When you press enter and then you go to the browser URL and you copy that URL in your browser and go to PyCharm and paste that URL in here, and then you will want to delete most of this So we're only interested of up to, you see, we have google.com search question mark q is equal to Python website. Then that's a search term. So after Python website, I want to delete everything. So that is the URL we actually want. I'm copying that and pasting it here. So if I run this, we still haven't implemented the input function, so just put anything there, press enter, and it searches for Python website. But now let's make this dynamic, so instead of Python website, we search wherever the user wants here in the input function. So I want to remove this Python website part and leave it at q is equal to, and then I want to say here plus user term. Let's try this. User term is Python and it's successful. So it searched successfully for Python. Let's try another one. Python official website. Press enter and it's successful as well. So that is how you can implement a simple browser search program. Now obviously Python official website is with spaces, but still these will work. If you wanted to replace the spaces with pluses, you could do that by using here a replace method. It's a string method since this is a string, so replace a space with plus and things would work the same. Python website, it searches for Python website. So that's about web browser as well. So those were the 4 modules I wanted to introduce you to. Thanks a lot. See you later.